Welcome, everybody, to the MIT Sloan Innovation at Work series, this time on LinkedIn Live. Great to have you here. My name is Eric Bergemann. I'm a Senior Director of Executive Education here, and I'm very pleased to be hosting this LinkedIn Live event, Deploying the Industrial Internet of Things to Create New Business Value, with our guest, John Carrier, my colleague who is a senior lecturer at MIT Sloan, and Omar Thorpe, who is the Director of Global Asset Health at Stanley Black Decker. So a little bit on what we're going to do this morning. Three things. The first thing that we're going to do is talk about an approach to Industry 4.0 implementation that we think is distinctive and speaks to the qualities of observation and visibility that can really help you to improve business performance. We're going to share examples of applying the principles from this approach, including some examples from Omar, who's our guest. And we're going to hear from you about your own implementation, questions and suggestions. We'll be monitoring the chat throughout. So just as we kick off, one thing that we like to do is understand where you are coming from and what your experience is. So if you could put into the chat an answer to the question, what industry are you coming from? That would be super helpful to us. So fire away. We've often found one of the reasons that we ask this question is that we have found that there's been a big change over the last year. Here we go. Life sciences, I see right off the bat. Large increase we are seeing in life sciences people coming in. Pharma, again with that. Agrochemicals and seeds. Mining, metal manufacturing. Tech automotive. So I think one of the things that I take away from this is that Industry 4.0 is increasingly becoming a dominant paradigm in how people are approaching their operations, particularly their industrial operations. So this is great. I have a second question for you now. And the second question is, can you please let us know what's your level of experience in your Industry 4.0 implementation? And we'll sort of use a three-point scale. You are fully implemented, your operations are talking to each other, you know exactly what's going on, you've got data coming from everywhere. Second would be you're getting there, you're running some pilots, you're scaling up, we'll say. And the third is we haven't started yet. We're looking for help. So if you let me know that, that would be terrific. This is our second question. All right, as we see people who are underway, I think I see a Francois Sauer, I think I saw is fully implemented. That's great. I see a lot of twos, which indicates you've gotten started and you're showing some progress, but your journey is underway. And John, I would have to say that's pretty consistent with our experience in the work that we do in our Implementing Industry 4.0 program.
Yeah, absolutely, Eric. And this is the part where we've, because we're starting to apply these techniques, we're familiar with the technology, but actually we're starting to understand our own systems better and how to improve that digital adoption cycle. Great.
Okay, so I'm going to hand it over to John, and I should introduce John, my good friend and colleague. John Carrier is a senior lecturer at MIT Sloan. He is in the System Dynamics group. John teaches in our Leaders for Global Operations program. He's also the faculty lead for our Implementing Industry 4.0 program. But John's also got a long background as a practitioner in industrial operations, has spent a lot of time on the shop floor, and has observed the transition firsthand over the last 10 years as you all have gone to the process of wiring your systems up in ways that you did not before. So John, I know you've got some framing here that you'd like to share to talk about what we've called this distinctive approach to Industry 4.0 implementation, which says basically it's not just about the technology. So John, I'm going to hand it over to you.
Great. Thank you, Eric. And just a little more about me. I spent the first part of my career at MIT in the engineering department studying control systems. And I spent the second half, which is really in my 15th year, is working in the business school. And so we're not only interested in technology, but we're also interested in how do we apply this to businesses to not only make them more profitable, but also make them safer and more agile, adapting to their environments, as well as making them a better place to work for the employees. So our agenda today is first, we're going to discuss a unique system dynamics based approach to implementing Industry 4.0 based on two very important concepts from process control: observability and controllability. In particular, observability, because that is always the first step when implementing Industry 4.0. And we're also going to share some success stories from people who've been in our course. I'll share some examples, and then we also have our guest, Omar, from Stanley Black Decker with us. And of course, the third part of our agenda is always have fun while we're learning. So really looking forward to being with everyone here today. So why are we here today? Well, if you look at basically the estimates for the size of this markets, McKinsey estimates this as a $10 trillion opportunity, and it's an opportunity across basically every industry. So first, how can a technology actually across all industries? Because 80% of Industry 4.0 is the ability to share and communicate rapidly globally across the world, and then react in our processes, systems, and supply chains to basically catch up with this tremendous improvement in communication costs and reliability. However, recent BCG studies show that about 70% of all the opportunities fail to meet expectations. So how do we understand what is it about the 30% that leads to successful implementation, and how can we make sure that we move into that top level? And what are the factors that separate success and failure? And what we're going to talk about here is really the first step in system dynamics. Was your first step is you want to observe the system, and then all the other steps follow. So sequencing of your Industry 4.0 initiatives is really a critical factor to success. So a classic trap or mistake we get into is falling in love with the technology without thinking about the system that it's going to be used in. So here's an example. We're all familiar with these virtual reality or augmented reality types of glasses and helmets, and they offer tremendous opportunities. Think of the ability to project work instructions to someone in a high hazard, high productivity industry like aircraft manufacturing, or here's a prototype from NASA, right? Well, while this is amazing technology, you can actually see that it ignores the system and the user. So typically with some of these technologies, even though they're invested in, they're not adopted on the factory floor. And here you can see the issue that the person loses complete situational awareness. And I also recently visited a major aircraft manufacturer. They were prototyping the most advanced type of virtual reality glasses. And after about 15 minutes, the front line was rejecting them. The reason? The batteries were overheating their heads. So they basically rejected this great technology because we didn't think about the system. And I'd like to show you a clever solution that's a little bit lower tech, but produced much better results. Instead of putting this helmet on people's heads, which takes away some of their observability, why don't we just project the plans on the workpiece? So this is essentially the same problem where they're constructing an aerospace capsule, and now they're projecting the location of the bolts, not on glasses, but on the workspace. And what's interesting, when we were discussing this example, they apologized because it was so simple compared to high tech. We are motivated to deliver results. So we very much enjoy simple technologies that change the productivity and reduce the risk and improve quality in any system. Okay. Now we're going to move from the world of aerospace and augmented reality into something we can all relate to here on Earth, which is beer. One of our colleagues who attended our course, going back to their work, they had a problem. They were working with a major brewery, and that brewery was losing significant capacity due to switching bottling lines. So their proposed solution was to invest at least $10 million to add 2 more bottling lines, right? So based on what the learnings from system dynamics and observability, our colleagues went and saw where in the system are we holding up the capacity so we can't actually maximize production of the existing lines we have. And based on that clear question, the answer became very simple, which is when they observed why their existing bottling lines were standing around, it turns out that when there was ever a defect or they had to shut down a line for a changeover, it required paperwork to be filled out by the scheduler, which you can see on the top, right? And even though there's about 15 minutes of actual work in filling out that piece of paper, tracking down the operators and the relevant people to get that information made it take 4 to 6 hours, right? So essentially the new solution you can see in the bottom is put this, automate this schedule, put it on the cloud, and instead of using humans to transmit the data, use sensors, right? Now, that's all technology that's very affordable, and this was implemented for under $100,000, yet the company was able to produce 1 million extra cases of extra beer per month based on this 6-week project. So first is stop and observe where we're losing our capacity, and then use Industry 4.0 to get visibility and observability, and often a very relatively simple solution can produce massive results for the facility. Okay, now how do we generalize these concepts from augmented reality and making cases of beer to realizing value in your system? And one of our learnings from our system dynamics group is when you actually think about a system, your customer cares about the output. So you can see that under the observable, right? And customers know how long they wait for something, right? That's very observable. But what isn't observable is what in your process or system kept them waiting. And there's really 3 types of activities. First is you need time to produce and make it. Second, which is in green, is you can customize things. So then customers have to wait for that. But there's this third area where things are being produced in what we call hidden factories that aren't observable, but they're actually delaying delivery of that product or service to your customer. And they're also wasting your internal resources, right? And that's reducing uptime and quality. So the technologies of Industry 4.0 can help reveal those hidden factories like we saw in the brewery at a very low cost, and you can recoup that lost capacity and your investment. So where we're moving to now is instead of always thinking about cost and profit specifically, start to think about time. If we can recover lost time, we can make things our customers will pay for. And that's where you can really find a business model that you can not only justify to your investment team, but you can also realize results in between 6 to 8 weeks, especially in the case with beer. Okay, and with that, can give you some success stories that we've had in our course, as well as some of the concepts we use in observability to basically find those areas for your best projects. And before we move on to our live guest Omar to talk about his success stories, just Eric would like to check in with you if there's any interesting interaction from the audience.
Sure. Thanks, John. So one point, which also gets to something else that we talk about in this, from Umberto Cena commented in that when you were putting up the helmet example, Yeah, people and the change process are regularly passed by. I think Umberto, unfortunately, we find truer words are never spoken. The good news is that when people in the change process are incorporated, good results happen, including the creation of business value. Any other comments from anybody based on what John's just said? CVK picks up on time as the new business model. Yeah. Stephen Mandel's got a question, John, about do hidden factories equal subcontractors? Do you want to field that?
Between 30 and 7, the answer is being sometimes a subcontractor myself. Yes, I am sometimes a part of a hidden factory. And I think you raise an important point is hidden factories are there because the system needs to accomplish something that leadership isn't aware of. So in fact, using excess capacity over time, sometimes bringing in 20 to 30% extra help through subcontractors may be a hidden factory if we're basically repeating the same inefficient steps over and over again. So that is an excellent place to start looking. What is it in the system that's pulling us to pull in extra work when it wasn't in the plan?
Great. Thanks, John. Any other comments, questions? Yes, I see Nastarin said systems thinking is the necessary skills for designing any successful solution. We of course like to hear that in MIT as a systems place, certainly in complex organizations. I think we got one more. Vishnu Vartan asked about what about process time?
I'm sorry, Eric. What about process?
What about process time? Yeah, Vishnu.
Process
do you want to
time?
say? Yeah.
And I think the way I would address that, Vishnu, is when you really look at process time, there's actually two times. There's the time, the elapsed time the system takes to make something, and then the total time the system consumes to produce it. So what I mean by that is when you're running a large processor system, it produces an automobile or an airplane every minute, hour, or week, yet there are hundreds or thousands of people actually in those minutes. So what we're really trying to do is basically keep the process time running efficiently, but by really maintaining and watching how the 100 people behind that system minute are synchronized and working together. And Industry 4.0 is critical for that because now we can actually measure what all those people are doing.
Okay, we've got there's one more question I would like to put in here since you've been talking about observability. Question is, why do we need to increase the observability? Does the customer seeing the factory process help in acceptance? Maybe a little clarity there on that. Yeah. And then we'll go over to Omar.
Okay. And I think I can help. I work in the part of my work is in the automotive sector where you have many tiers, right? And you'll know that if you're a large automaker like Toyota or GM, you're responsible for the quality and delivery time for a $25 million manufacturer. So if you are a senior leader at a large company and you buy parts and services from smaller companies, you're the one liable to the customer. So in order to reduce your risk, just having visibility in terms of your supplier's control charts, maybe certain critical factors for quality and defects is really critical of not only if you want to serve your customer properly, but if you want to sleep at night as well. Yep.
Thanks, John. Great. So, as we said at the outset, we have a special guest with us here today who is going to talk about his experience, particularly around observability and visibility. Omar Thorpe, who is the Director of Global Asset Health at Stanley Black Decker. Probably a number of you are owners of Stanley Black Decker products. Omar, great to see you again. Welcome you back. And you've brought some examples with you to share, and I think you're going to have some discussion with John as well here. about that. But Omar, the floor is yours.
Okay. Yep. Thanks, John. Thanks, Eric, for having me. And good day, everyone. So just to start out, Stanley Black and Decker, we have been around for well over 100 years. We have been a part of all the various industrial revolutions that have occurred, culminating in Industry 4.0. What I'm going to be outlining today are 4 use cases of the many use cases we have within Stanley Black and Decker in terms of how we're using cost-effective and easily deployable solution to gain better data on our factory floor. Just to set the context, our operations, they are primarily either asset-centric and or labor-centric, which means that when we're looking to pull the value levers, we're really looking to seek in terms of how we can improve asset performance and labor productivity as we convert our raw materials to finished goods to deliver to our products, right? And so key to that, we have to observe, we have to measure, and that's the only before we can improve. So that's what we're going to be focusing on. Next slide, please. So just want to ground the audience with some key learnings over the many years that we have been on our Industry 4.0 journey. The first one is really to have clear overall technology strategy that is scalable, but it should also be agnostic to any point solution. We shouldn't just be sensorizing for sensorizing sake. It has to be a part of our overall strategy that actually makes sense. We also have to be able to showcase what the art of the possible looks like, and to determine what that benefit runway is going to be. So, John pointed out that it's a $10 trillion addressable market that McKinsey study did within Stanley Black and Decker. McKinsey also came in and did a study for us, which determined that there was significant opportunity and what that benefit runway should look like. So that at least gets senior leadership excited and ready to put hands and heart behind the effort. The next key step, which is what we're really going to focus on, is to start to use use cases to gain buy-in at all levels. This allows for quick wins. It allows to develop momentum within the organization. And then it actually leads to the 4th step. It allows us to learn, iterate the process, and then to scale going forward. Thank you. Let's go to the next slide. All right. So the first use case here is around measuring real-time OEE monitoring for shop floor performance. This is a use case which comes from out of one of our Malaysia facility. One of the key supply chain metrics that we actually use within Stanley Black and Decker is OTIF, and a leading indicator and OTIF stands for on time in full. A leading indicator for OTIF is actually overall equipment effectiveness. If the equipment is available, running at the right rate, and producing right quality parts, it impacts our ability to deliver to the customer on time in full. And so therefore, on the manufacturing floor, it's very key for us to measure this. We chose to look at the cold forming headers, because that represents one of our top 5 asset categories at Stanley Black and Decker and at this facility. In doing the implementation, it only took a matter of weeks to get the instrumentation done. Quite a bit of the data was really already collected, but it just wasn't collated and presented in a format that really made sense to the factory floor for real-time decision making. So what we did here, we were able to start capturing that OEE data, showing those trends, and you'll see those red lines where the OEE dipped for various reasons below target levels. From that, we were able to prove out concepts where we were able to create messaging alerts through WhatsApp, through email, and other sources to the key stakeholders on the factory floor so that they can support decision-making process. What I want to highlight here is that a lot of times the information is already available. It's just not necessarily packaged or presented in a format that makes sense for the factory to make the right decisions. I'll go to the next use case.
Great. And thanks, Omar. I just I like this example so much. I just want to add one quick point is so many places we go visit, they're like, do you have this information? Like, yes. And then you wait, you go, no, do you have it so we can see it? And like, oh. And if you can't observe the information, you can't take the right action. And I think second, you may have learned, Omar, is when many people at the company can see the information, all defects are shallow, right? Someone's seen it before, someone can correct it, someone can help you. But unless you put it in a beautiful visual form where people can observe it, we can't take advantage of that. So just love this example, Omar, around observability. Now we'll move to the next slide.
Yep, absolutely. Yep. The second example here is from one of our operations in Missouri stateside, where this was part of a two-phase project. The first phase was to prove the concept where we can get the potential predictive analytics. And then the second phase, once this worked, was to be able to link the system into our CMMS system, or that's computerized maintenance management system, so we can start the automatic work order generation. The end goal was really being that the asset will be able to actually identify itself on the network, broadcast its current health, and then instruct operators and maintenance in terms of the actions that it should take to either extend remaining useful life or the maintenance action required to keep asset performance levels. So the first step was really just around putting some vibration sensors on one of our paint lines, which was a critical bottleneck. If the paint line goes down, the entire production of the operation stops. Focusing on that paint line, the key component was really the paint delivery system and really the paint pumps. So using vibration sensors was really the appropriate technology to use to understand the performance on that line. We used both wired and wireless sensors that were installed. The setup was really easy, and to put these wireless sensors on, we did that in only a matter of hours. The cost to implement it on a machine was about $200 to $500, depending on the number of sensors that we wanted to put in place. And then once we were able to do some quick checks that the sensors were working and everything was uploading through the system and onto the network, we had some AI in the background that would do the anomaly detection and analyze the vibration spectrum and then issue those asset health scores. One of the key things with this is that it involved very little human interaction. The data was able to be automatically streamed, and we did have some savings. For one, we didn't need to actually have a vibration tech to actually read the information. The information was uploaded to the cloud. The AI was able to do the analysis and replace some of that heavy lifting that the analysts would do. But more importantly, the system was able to predict and make the right call for intervention, I believe about 5 out of the 6 times. So 5 out of 6 times, the system made the right call. We were able to prevent an unplanned outage, and that really, really impacted our cost.
Great. And just a few observations, Omar. First is when you talk about how important this paint equipment is, if it doesn't run, the whole factory shuts down. So that's an expensive minutes, very valuable, right? And to be able to capture those minutes with basically a low-cost vibration sensor that takes a few hours to implement, and actually it's all electronic and automated, is a huge change of where we were even 10 years ago. I remember buying the sensor used to cost around $1,000, but you'd have to wait 3 to 6 weeks for the instrument tech at your company to install it because they were so busy. And now, you can do this in hours, and it's some are wireless for as well. And I just want to add one last point is when you're using electronic information, it's not very effective when someone turns it into ink and paper, and then it has to go back to electronic. So this ability to actually stay electronic with the information in that feedback loop is not only fantastic, but really only possible over the last few years. So thank you, Omar, for the great example.
Yeah, okay. Absolutely. The next example here is really interesting. As I mentioned at the start, a lot of levers is really around asset performance or labor productivity. This one is around using the video analytics to monitor labor performance. A little bit of context. This is from one of our operations in the Carolinas here in the US. This came about because we were consolidating different final assemblies from different plants into this particular location. As I mentioned, the process was very labor intensive, and we really wanted to understand the labor productivity and the line balancing between the different stations. So we partnered up with a vendor to install these video systems. The installation took about 2 weeks. It took us another 4 weeks to actually train the vision system using input from the assemblers. So if you will notice on the screen, we had the steps where we're doing the transmission gear, aligning the transmission gears and so on. And then the active step that it was showing there is really on the the assembly engine subassembly, where it was running about 2.4 seconds. We were able to actually link the system through APIs into a workflow engine in order to determine takt time variability and line balancing issues and be able to parity those out. It may not be clearly seen on the screen here, but in the center, it's showing the variability in takt time in our different workstations against target. We really discovered some interesting results here once we started interrogating the data. One interesting concept was that a lot of the variability was around preference, operator preference to use one particular station over another. Some of those preferences were driven by the fact that the newer stations were more ergonomically designed, and they even had some good anti-fatigue mats that were used. We found out that once we were able to replicate some of these processes, we're able to reduce the variability. But having these vision systems here really allowed us to interrogate how our operators were assembling and be able to make the necessary corrective actions.
Great. So thank you, Omar. And this is a fascinating example because now we're seeing an opportunity for having computers and technology work with people and letting them allow each what they do well. And I just must add, it's very interesting because when most of us do variability and takt time studies, it seems like it's people's variation, and it should be put on the person. And you've actually outlined through data that really the system around them is determining their behavior on ergonomics and fatigue. So just a fantastic example of how technology can actually empower and enable the front floor, the front line, rather than actually subtract from them. So great example, Omar.
Yeah, absolutely. And then our last example here comes from one of our plants in the UK, where we were looking to get asset performance data on our coal forming header. Here we did a little deeper dive. We looked into the physics of failure to understand how the machine would actually behave and perform, and what was the right information that we would need to collect in order to detect change in the performance and or the condition of the asset. We found out, but through the physics of failure, we have to look at the pressure required to form the part, the associated energy to generate that required pressure, the motor current and vibration, and then we all fed this into an analytics engine. We installed quite a few sensors. Time to implement was about 4 weeks, is my understanding, and the cost was, just a little bit under $1,000. So not significant, just to get these sensors up and going and connected. One of the key points here is that we actually worked with the data scientists and plant engineers to figure out what the anomaly detection would look like, and developing some of those failure mode engines that we then would be able to use as our stepping stone in order to ascribe asset health and asset performance. Key here in addition to the technology and the fact that we could set it up very, very quickly and very inexpensively, it was really the collaboration with the data scientists and the experts who actually know the asset, know the value stream, and know the plant conditions, so we can actually get insights from that data. This actually led to less trial and error. When we implemented the solution, we had better analytics, better presentation of the data, and that made better sense to the plant stakeholders for them to take proactive action. And so that's key. Thank you very much, everyone. Those are the 4 presentations that I have. And
thank you, Omar, because you covered just an incredible amount of operational improvements in a very short number of case studies. And just want to share some things on use case 4. A problem I come up with frequently is on data scientists. And, I like to say data comes from somewhere. So you actually have to, it's not simply observing the data. That should lead to questions observing what system generated it. And I love the fact that you, it's Stanley Black Decker, encourage your data scientists to go see the work and understand the value stream. Getting the different, this leads us to an opening question is, you've been very successful in getting multiple groups on board, right? Frontline operators, data scientists, your investment and finance people. Did you encounter any initial resistance? Because, sometimes this data might show that maybe things aren't going the way they should, because that's where the improvement is. Did you have any initial challenges with adoption, and how did you rectify those?
Yeah, we had many challenges with adoption. Again, for senior leadership, we made sure that we were able to articulate the case and what that benefit runway would look like. The example that I showed in case 3, where we're doing the video analytics, there was quite a bit of resistance at the factory floor. So we kind of knew going in that we actually needed to work with the operators, give them time to acclimate and get comfortable that their tasks were going to be observed, and then actually engage them in the solution in process. And I think that's really what works well. The approaches that we tried that were very top down, to focus on speed of execution and not necessarily engaging with the plant personnel, lead to suboptimal results. But as the case number 3 highlighted, engaging with the factory floor, having them being a part of the solution really helped, and it supported user adoption.
Just a great lesson, and is invariably successful when we engage. It's their system. They work there every day. And a little shocking at how often we forget to start with the front line. So thank you so much for that, Omar. And as we're starting to roll in questions, we have a very good question around one of your earlier case studies around Industry 4.0 and this new observability versus Industry 3.0, where we were using, your basic dashboards for tracking production, tack time, or whatever we used in factories previously. Did you see clearly it looks like you saw a big advantage in moving to Industry 4.0 from traditional Industry 3.0 dashboards. Any thoughts on that?
Yeah, so the advantage came, and some of it is we have already mentioned. The advantages came from being able to actually connect the asset to the people who are making decisions, being able to speed up the decision flow. But I think more importantly, what it actually highlighted were just some of those inefficiencies that existed within the plant, right? And going to that in 4.0 really gave those. Going through Industry 4.0 gave us some of those benefits.
Great.
Yep.
And thank you, Omar. And also is even from my own experience, the industry 3.0 dashboards didn't always have as good of sensor data. And since they were local, they weren't always updated and reviewed, right? So you now basically this is observable to anyone within Stanley Black and Decker around the world who needs to see it. Great. I also wanted to talk about when you started implementing these techniques on the floor, you're collecting a lot of data, right? And you're doing analysis that's being used in real time. Was that implemented on the edge, or was that implemented on the cloud, or a hybrid? Maybe you might help us. What's your data handling strategy for your facilities?
Oh yeah, absolutely. Very good question. It was a hybrid approach. There were some point solutions that it just made sense to implement those on the edge. As I mentioned with the vibration analysis, those solutions those were implemented at the edge. Reason being, our strategy called for a process where we could actually mix and match different point solutions, and therefore having them at the edge just made sense, right? In terms of from a strategic point of view, where we're looking to do more of the detailed analytics and understanding the value stream, those solutions we actually implemented within the Stanley cloud, where we could host that data and be able to act and respond upon on the information it's providing more real time.
Okay, so a very interesting philosophy and as guidance to what do we keep at the edge? Real time information that we need to do point exercises. When we're actually extending that to the entire overall system, like a value stream, a larger audience needs to see that and see the history of it. So it's a nice way of thinking about how we store and share information. Great. And Omar, we have another question. It's diving again into your use case 3, where you were using visual recognition to watch, identify how people were using tools and their tact time with using those tools in assembly. Were the workers aware that they were being recorded, and did you face any issues with people's trusts?
Yeah, so they were absolutely aware that they were being recorded. So we actually engaged early to build trust. We engaged early. We told them what we were looking to do. We involved them in the placement and positioning of the cameras, and that reduced the hesitation that the workers had. Right, without that early engagement, because we have learned from other experiences, without that early engagement, resistance is very high.
Great. And building off this example, obviously, when you started, modeling time, you not only get more productive, but your lead time to build something shrinks. And I'm curious. We talked about how this benefits, your own system within your 4 walls. But what benefits did your customers see from greater visibility within your system?
Yep. So great question. One of the key benefits that they actually saw, to my understanding, is that they were able to better understand what were some of our piece part variations. They were better able to understand from issues with line balancing if we were able to actually meet our OTIF requirement ahead of time, and then have those conversations in terms of what the corrective action would be needed. So just having that simple insight in terms of how the line is performing, what variability is occurring, really helped us.
And it also sounds like your customers benefit in your supply chain, benefit from this observability as well. So one of the great concepts we're learning in Industry 4.0 is this concept of observability. When we start in our own facility, actually starts to produce benefits both for our suppliers and our customers, because they know what we're going to do, when we're going to do it, and they know how to help when we have an issue. So thank you for that, Omar. And we have a question from Augustin, and he says, tell us about the transition in terms of business and operational processes and organizational design. And I think what he means is, you see the improvement, but that doesn't mean you've actually integrated it into the way the organization does its work. Can you tell us a little bit about that?
Yeah. So I'll try to do it as succinctly as possible. So one of the key things that in implementing this technology, we have to actually look at what the technology readiness of the business is, and then what the workforce readiness of the business or the operation actually looks like. So when we look to implement the technology, we look at how the decisions are being made. We look at how the human actually interacts with information. And we do that as part of the technology readiness and workforce readiness profile. And then we adjust our business processes incrementally to accommodate.
And Omar, I just love the point is, first, you not only have to know your future state of where you want to go with Industry 4.0, you really need to understand your company's current state. And I think you've elucidated several times that it's not just the overall organization, it's the specific facility, plant, or area to spend the time to observe their current state before the transition. And I think that relates to Augustine's question. When new business processes come in, old ones have to go out. And because if they don't, you create hidden factories. Okay, great. Just as we go through this discussion, Omar, any thoughts or suggestions for our colleagues who joined us today regarding making their Industry 4.0 transition?
Oh yeah, absolutely. I think there are about 5 key learnings that I'd want to share. The first one is around understanding the current reality and maturity of your organization operation in their Industry 4.0 journey, and meet them where they're at. If your plant or operation is barely at the stage of in implementing Industry 3.0, it's probably going to be even significantly more difficult to implement 4.0. So understand that current state and meet the operations where they're at. The second thing is around focusing on solving a real problem or pain point for the business. Don't just sensorize instruments and communicate data for communicate's sake, but focus on those key problems. That allows us to show a clear line of sight in terms of how the technology deployment actually aligns with the near-term business objectives, and then creates a much smoother glide path for future technology deployment. The third thing is try to avoid technology fatigue. One of the things which we found, you had different groups coming into the plants and wanted to implement these different whiz-bang technologies and solutions, but it has to be incremental. One of the things I would ask the audience to do is input new technology alongside tried and tested systems, right? It will make it easier because once we do these proof of concept, sometimes it may not work. So it will make it easier to go back to status quo and avoid minimize business interruption. And then if the technology really doesn't work because it has that minimal impact, it allows us to fail forward faster. Then I think the fourth thing is start off with a minimum viable solution and build in complexity later. That's key. And I think the fourth thing is really around make sure that the application, or the fifth thing I should say, make sure that the applications deployed are usable, useful, and user-friendly. If they aren't, it doesn't matter how great the tool is. If at the point of solution, the person is not able to use it or interact with it well and not able to engage, you could actually have a flawed technology deployment, not because the technology doesn't work, but because it just wasn't engaging for the users. And
thank you, Omar. And what an excellent set of points for our colleagues online. And really, the technology obviously attracts our attention, but spending time to understand our existing system and its needs. And also, I do love this one about avoid technology fatigue, right? And because people need to do their day job and their day work. So this is a moving system. So thank you again for those fantastic case studies, Omar. And just as some final thoughts, really, when you look at a system, time is the ultimate system property. And Omar, as well as some of the examples I showed, show we're really watching time and how our system's spending it, and then we're making improvements for everyone. And in several of these examples, the observability gave us the opportunity to rethink of our assumptions and not make things worse by just adding technology onto a existing assumption we should change. Second, I use the term win the fire drill, and it's very much related to Omar's concept of get that minimum viable product up and running. So what we mean is test and prototype, get it working before you actually put it online in full production, right? Because you can't afford to shut down that paint line for something you could have learned in an experiment. And then finally, I'd like to end with watch your language. And what I mean by that is as we start to do these transformations, clear communication is key. So using a smaller set of words and definitions and terms that are common among the organization is really critical if you want to accelerate your digital transformation. So thank you again, Omar. It's been just a great experience with having you here and talk about some of the successes that you've enjoyed since we had the opportunity to be together in the course. And with that, I'd like to turn it back over to Eric.
Okay, thank you.
Super. Thank you so much, Omar. Thank you, John. And thank you, everyone who joined us today. I see in the chat there's a number of questions about what is MIT Sloan ExecEd's offering in the Industry 4.0 space. And my colleagues have put a link in there. You can register for this program at our website, executive.mit.edu, or follow the link directly in the chat. Our next delivery is April 25th, 26th, 27th. So just about 2.5 weeks from now. That will be live online. And we also will have our first in-person delivery at the end of June as well. But we'd love to see you coming up in the upcoming program. Again, we thank you so much for joining us here today.